Hi people, welcome back. My name is Madhu Kashyap. I'm a physics educator at an academy. I'm an astrophysicist from Bengaluru. I'm a young scientist awardee from Indian Science Congress and a young researcher awardee from European Space Agency Netherlands, and also an author of a book. Welcome. I'm just looking at my screen right now to share my link to my students. So where are you, Mr. Link? So we will be doing observational astronomy, and we will be talking about celestial sphere to begin with. Okay, let me just close this, share, Telegram, and Mike. Okay. Where are you? Okay. Okay, let's start. So about celestial sphere, we are going to start with celestial sphere. And when we talk about celestial sphere, so it's an imaginary sphere, guys. Okay, celestial sphere is an imaginary sphere. Okay, what happened here? Okay, let me just put my pen pointer on top. Okay, so imagine there is a, my pen seems to be having an issue today. Okay. Okay, I just wanted to see how that worked. Okay, let me just put this in order. Okay, now we are gonna just draw a circle. Okay, imagine this is our Earth. Okay, just remember the heliocentric model. Earth was at the center and everything was there. So when we talk about celestial sphere, it's just an imaginary sphere around an observer. Observer is the one who is observing right now. Let us say the observer is here, at the point O. Okay, and there are celestial objects outside here. Let us call it as A, B, C. These objects can be planets, stars, moons, all those things. Okay, any of those celestial objects. So let us draw a dotted line till C, dotted line till B, and a dotted line till A. Okay, the distance from the observer to this celestial sphere to the observer can be anywhere from 0. This observation range from 0 to this small a, and here for B, small b, and this one will be for C. Okay, so anywhere. So this is with respect to these particular objects. So with respect to A, the observer can be from anywhere from here to here, or for the observation of an object near B, so the observer can be from here to here. So that's how we try to understand a concept called as celestial sphere. So this is basically having a outer sphere, so just an imaginary outer sphere. Just like Earth having an equator, and Earth having North Pole, South Pole, we have celestial North Pole, celestial South Pole accordingly. Okay, so with that, we need to understand very much the basic part of spherical coordinates to go further. Okay, I know you guys would have studied spherical coordinates when in your mathematics, especially the ones who are doing the conic mathematics, the coordinates and all those things in detail. So you would be learning, and also those who are doing the class 12 students who are doing electromagnetic equations, you do need to know that. Right, you do need to know that it's very important that you understand the polar and spherical coordinates. I know you guys study Cartesian. It's very much important to know the other things too, like the celestial and the other coordinate systems. Okay, so now the celestial coordinate system, Omar and G is commenting well. Thank you. So if you imagine this coordinate system, so imagine a sphere. Inside that there is a small circle. There is a chota circle, small circle. Okay, small circle. And we have something at the center called as great circle, because we know at the center the diameter is large. The chord's diameter is the largest, that we call it as diameter, which is the largest chord of the circle, which we call it as great circle. Great circle. This is called as a small circle, and this is called as great circle. So where you can mark any 2 points here. So let us draw one center line here. and mark these points as P and P dash, where P and P dash are poles. P and P dash are poles. Okay, here we can mark two more points on the greater circle, calling it as Q and Q dash. So Q and Q dash are the shortest path. Okay, Q and Q dash are shortest paths. Shortest paths. Array, my pen, China pen, always gives me this headache. Shortest paths. Okay. So that's how we understand this particular spherical coordinates with great circle, where the plane through the center of the sphere, it will split the circle into two identical hemispheres along a circle called great sphere. Okay, and then the small sphere is basically giving you, imagine if an ant going on an apple. For we know for us the shortest distance is a straight line going from point A to point B. If an ant is walking on an apple, for ant actually the apple is the straight line, but the shortest distance it is taken by the apple is a geoid, or a it's basically a geoid, which is the shortest path taken by the ant. Okay, that's how we understand this celestial spherical coordinates. There are different notations which you can go and look at some of the recordings of in the unacademic courses. Okay, for the coordinate systems, for the mathematical part of it, you can go deep. Actually, that itself can be a what to say, it can be a one semester syllabus of all the coordinate system, polar, Cartesian, spherical coordinates. All these things can be a semester by itself. It depends on the observer. And when we talk about celestial coordinates, coordinates, we are talking about there are different types of coordinates. We talk about something called as, ours is very straightforward. We call it as terrestrial, that is Earth coordinate system, right? Earth also has a coordinate system. We call it as terrestrial coordinate system. Terrestrial coordinate system. What is this terrestrial coordinate system? It is nothing but latitude and longitude. Okay, so phi is latitude, L is longitude. Here this is latitude and this is longitude. We know this, very basic, our Earth coordinate system, terrestrial coordinate. This is the language we use as latitudes and longitude, right? So then we have something called as horizontal coordinate. You can call it as horizontal, or you can call it as azimuth. I'm gonna tell you what is azimuth or azimuth coordinate system. Okay, azimuth system. So it is represented with respect to A and alpha. A and alpha. What does this mean, horizontal or this particular azimuth thing? So it's basically a two-dimensional coordinate system. This is a 2D coordinate system. Okay, so imagine the celestial sphere. Okay, and what we do is, there is a I have to draw the diagram and show you. So it's basically when we talk about this is azimuth angle, and this is called as altitude angle. This is called as azimuth angle A, and this is called as azimuth altitude. Okay, so this is basically finding the ranges with respect to the two-dimensional celestial sphere. Azimuth altitude. Altitude is height. So based on the two-dimensional, if you cut it into half, if you cut the big celestial sphere into half, and you have only the part of the celestial sphere where we call something called as zenith. Whenever you lift your head up and see whatever point in the sky, that will be called as zenith. Zenith is a very important term in astronomy, and we use this quite a lot in order to describe an angle. So zenith is a very important terminology. Zenith is something everybody, for example, if my student Om Narayan is here, so if my student is staying somewhere in say UP, okay, he's in UP right now. So the zenith for him, whenever he stands and sees up, that will be the zenith for Om Narayan. For me, I am in Bangalore. If I look at my sky above my head, that will be my zenith point. Zenith is just above your head. Zenith is a point. Just when you lift your head up, whatever you see, that will be your zenith point. Okay, and below, opposite to zenith, there is something called as nadir point. Okay, we call it as nadir point, nadir, nadir point, which is the opposite end of the zenith. Okay, so azimuth angle is basically when in the celestial sphere, I can draw that. Maybe in the next class I'm gonna draw the diagrams and go in detail of how these angles works. I'm just introducing today observational astronomy. In the next class I'm gonna draw the diagrams and show you how these angles and altitudes, everything come along with. Okay, so next part we have some more coordinate systems. So this has lot of coordinate systems, so we need to understand many of them. The next is called as equatorial system. This is a very popular one which we use in astronomy. It's called as equatorial coordinate system. Equatorial coordinate system. Okay, so here this is the one which we use very much for knowing the coordinates of the astronomical objects. This is very popularly used. It's called as right ascension RA and declination delta. This is called as right ascension, just a second, let me put it in order, otherwise I keep okay, so we are talking about here with respect to right ascension and declination. This has to do with a constellation called as Aries. Okay, so when we talk about right ascension, this is called as right ascension and delta is called as declination. Okay, this is actually right ascension. You know what right ascension and declination corresponds to? When you talk about latitude and longitude, you know declination corresponds to this as right ascension corresponds to longitude and declination corresponds to your latitude. Okay, that's the beauty of it. This is basically your longitude and this corresponds to your latitude in your Earth's language, terrestrial language. Okay, we will go in detail, in deep with respect to these things. Mouliji is present. Nice to see you here, Mouliji. So these are right ascension and declination. It has many advantages. It is independent of place and time, and it is fixed. And you know it gets updated every 50 years. We have something called as epoch. So every 50 years, once in 50 years. So if your age is around 50 already, then when you are 100 years old only, this gets updated. So this coordinate system is based on fixed stars. Okay, like the pole star, the north star is fixed, right? So RA and basically for particular stars. Okay, basically for particular stars, we call something called as epoch, which gets updated every 50 years. Every 50 years once we update this RA and dec. So we started with observational, so spherical coordinates, so terrestrial coordinate system, horizontal, equatorial coordinate system, which is the most popular and most widely used coordinate system. There are some more. There are a couple more coordinate systems which I would like to introduce you to. Okay. Senior citizen is here. Okay. So the next coordinate system we call it as meridian. We have different types like meridian. Okay, this is not much widely used. This is called as meridian coordinate system. Okay, here we use something called as hour angle and declination. I'm gonna teach you how it looks in with respect to celestial sphere, how these angles, everything works. I can teach you only in the next class where I'll be bringing in diagrams, because without diagrams it's highly impossible to teach you how these coordinate systems work. Okay, so this is meridian. Now we are talking about another system called as ecliptic system. Ecliptic system. This is also another coordinate system. ecliptic coordinate system. This is meridian. Okay, so it's basically similar to your terrestrial system, okay, with latitudes and longitude. And one more ultimate coordinate system is called as galactic coordinate system. Galactic coordinate system. What is this galactic coordinate system? It has galactic latitudes and galactic longitudes, especially for very far away objects. We have something called as Gaia. Gaia is one of the telescopes. Sometimes it is easier for it to find certain objects with right ID. If you have Iron Deck, you can find the corresponding galactic latitudes and longitude with various websites like Simbad, Vizier, all these things you can use. But galactic coordinates are so cool. They use galactic latitudes and longitude. I don't know, for some reason I like this very much. It's very straightforward. Instead of using, I'm gonna show you how these things work: galactic latitude, galactic longitude. In the next class we will draw the diagrams and look at them in detail, because if I start today, the entire class can't be finished in an hour, because and my drawing skills are very bad. So it will be nice if I can bring you those slides for you galactically. So we will look at that, and what are the advantages of each of these things. I want to discuss what are the advantages of having. I did not tell you what are the advantages needed, or what are the advantages of horizontal or azimuth system. So it is locally convenient but not globally. This is locally convenient. Locally it is easier to find. Alpha and A are time dependent. It depends on time. So it depends on time, and so it is time dependent, and it is locally convenient. Globally it is very hard to use this, because it is dependent on on what place, in which place of the earth you are. You have to keep correcting. Very hard to communicate. For example, if you are in Australia and if I am in India, it's very hard to communicate globally. And this is the best to use. Okay, I have told you why, right? So, and it works for every 50 years only, updating is needed. So these are some of the advantages. So in order, why this last one is very peculiar, right? Why this is suitable is, it is suitable for solving problems for the structure of the Milky Way or on the motion of the Milky Way. Basically, we are concerning to the structure and motion of the Milky Way. We use galactic coordinate system in order to understand what is the structure and how our Milky Way is moving around. We use galactic coordinate systems. So these are the introduction for observational astronomy. So when you go into the night sky, every star, every planet, every constellation rise and set. Okay, except for one star which is called as pole star, which is the tail of a constellation star called as Ursa Minor. Ursa Minor is a tiny polar bear where the tail points towards the north direction. And this is one of the important stars when you don't have a compass or you don't have a star, a sun to navigate. So if you are in dark and if you have the night sky and if you see a north star, you know which is north, south, east and west. So that's one of the easiest ways to identify the directions. And rest of it is very much straightforward. And rest of the constellations, you can see many constellations, very famous constellations like Orion constellation, which is basically the hunter. So in order to observe that, all you can see, if you are a first time observer, you can look for a belt of a constellation Orion. You will see 3 bright stars. Okay, and you will see hands like this and legs like this, and you'll see a small sword coming out. So that's basically Orion constellation. Okay, so when you talk about Orion constellation, here this hunter is basically the reference point. Most of us, when we are starting to learn about the night sky, we start with something called as Sirius, which is the brightest star in the sky. And then near Sirius, we have these 2 beautiful constellations. One is Orion, another one is called as Taurus. So the way we recognize Taurus is by looking at a very very beautiful open cluster called Pleiades. Okay, Pleiades is a very beautiful open cluster. By looking at this particular cluster, you can make your own torus imaginations. You can use many softwares as well, like Stellarium or Google Sky Map or any of these motion sensor apps where you can note the night sky, which is fun to do. And yeah, there are many star, and also you can look at many other constellations, like the very famous constellations like the Ursa Major, which is a big giant polar bear where you have a tile, okay, which looks like a Saptarshi Mandala, we call in Sanskrit, or it looks like a big dip. We call it in English we call it as a big dip. So in that big dip, where we also look at many of these beautiful the one which we show in Hindu culture to show about the binarity and the marriage being together. So we show a binary star in the Hindu culture to say that you have to be, the husband and wife has to be together like the binary star. Anyway, but some people show it in the wrong direction. Anyway, that is a discussion for some other place. But yeah, these are the very basic aspects of observational astronomy. So we will go in detail about these particular things in the next class. You are able to identify only Orion and Saptarshi Mandala. That's good. Rest of it you will learn if you go along for a long time. There's a in front of Orion there is this Pleiades cluster, and you know the Sirius is basically the hunter carrying a dog, and that Sirius is basically the neck of the dog. Okay, see our the brightest star Sirius. And also you can look at constellations like Gemini, which is very beautiful to see, and there is something called as southern sky. Okay, most of us won't get access to southern. If you are in Himalayas, you will be not able to see southern skies. If you are in the southern part, like Kavlur or any other place, any other such place, then you will be able to see some southern constellations. We have something called as False Cross, Southern Cross, and there are some more beautiful. There is Eta Carina, which is one of the most beautiful epic object to see. Okay, you have to watch that, and you can see something called as Whirlpool Galaxy, which looks like a whirlpool, Crab Nebula, Horsehead Nebula, actually Horsehead Nebula and Fire Nebula. You can, if you put a very good 18-inch telescope or so, I think you will be able to. If you observe the belt of the Orion near the second star of the Orion, you will be able to see the Horsehead and the Fire Nebula there. Okay, and in order you said you can recognize only Saptarshi Mandala. Actually, other than that 7 stars. If you look at for the two stars coming in pattern, they are basically the paws of the polar bear, big polar bear, and the Saptarshi Mandala is actually the tail of the big polar bear. Your comments? Betelgeuse star update, please. Betelgeuse star is one of the stars which may go supernova which is the candidate for becoming a supernova. So you guys can keep an update. You can always look at there are many groups which are working on Betelgeuse updates. You can just Google them and you can find them in detail. So if you like this kind, actually I think the time has just ran out for me because I have something coming up. So what we are doing in the next class is we are going to look at the diagrams of how this celestial sphere, the terrestrial coordinates, the horizontal, the equatorial, meridian, ecliptic and galactic coordinate systems look like. Okay, and also we will learn some more techniques to look at the night sky. And actually it will be fun if we can arrange some kind of a night session, maybe in the future someday when time permits, maybe that will come true. Okay, tomorrow is tomorrow 10 p.m. we will continue on this with respect to these coordinate systems, and once we learn this, I think we can move to the next aspects of IQA and NSEA syllabus. Okay, until then, have a nice day guys, good night, and see you in the next class. If you like this kind of videos, please subscribe, like and share, and you can ask your friends to join in. And if you are I actually teach at an academy. If you are interested to learn from me, you can use my referral code MDK10, which is shown in the below. You can go to my profile and yeah, get a subscription there. Okay, thank you and have a nice day. See you in the next class. Take care. Bye bye.